Hello, everybody. Welcome to Olga channel. Today, I want to talk on linear programming. In my previous videos, we talked about matrices, talked about the inverse of matrices, how to solve them with Gauss-Jordan method. And then today, we are going to talk about linear programming. So, what is linear programming? So it's just a way or a method of solving what's linear problems. So each and every one of us faces linear problems day in and day out. That's making decisions between two things, either to come to school or towards go to the club, and then doing so you compare benefits, or either to do both in order to maximize your satisfaction. So linear problems are everywhere, and then we use linear programming to solve these problems in order to get in order to make what's a better decision. Okay, so the components or some of the main things you have to note about linear programming is you need to understand the problem. So linear problems come in the form of English. So one way to solve a problem is understanding it. So even before you can even start with the programming, you need to understand the content they're giving you. And then understanding the English, no one can teach you that. You have to know what this sentence means, what that sentence means. You get it? So with linear program, you have to first understand the English that they've given you before you can translate it into mathematical form. So that's what today we are going to talk about, which is what linear programming. Then with linear programming, we have a part where it's about just formulating the formulating the issue. That's transferring the problem from English language to mathematical language. That is the first aspect of what linear programming. The other one deals with what solving the problem. That's coming up with what a decision, right? So we solve problems towards make our lives better, right? So the second step is what to solve what's the problem, and the last step is what interprets the problem. It is not enough to be able to put formulas together, get what the solution to a problem, but it is complete when you're able to interpret what your solution means to the other person. So let's say in a business setting, there is a linear problem. That's what should the business produce? Then you solve this, you've gotten some figures. The management is not interested in all those big figures. They're interested in, so what should I do with the figure? What should I do with the figures? How are the figures going to help me solve or what make certain decisions in the business? You get it? So today we are going to look at the formulating of the problem. That's changing it from what English form to what mathematical form. So that's what we are going to deal with. And if you like this video, then subscribe. Then move on to how to solve it. And then we have various methods of solving them. I use a graphical method depending on the number of what decisions you have to make, or use the computer solution or the computer form, that's Excel, to solve the problem. But today I'm going to look at what formulating the problem as or the issue, translating it from what English to mathematical form. That is what today we are going to look at. And then there are certain things that we have to note, certain keywords that we might find in the, the statement containing the problem, right? All right, so the first thing that we should note is when you're given a mathematical statement, that's a linear problem, and you want to translate it into mathematical form, there are 4 things that you should look out for because you are using the linear programming. And then the first thing that you are supposed to look out for. So now we are on the formulating of what the issue or the problem, translating it to mathematical form. So the first thing you have to note is know your decision variables. As what kind of decisions am I bothered with? What decisions am I supposed to make? So when I talk about decision variables, because you don't know the what type or the decision you are going to make, we would use unknowns, that's variables like X, Y, to represent the decisions we would make after solving for them. So you have to know the decisions you want to make. Am I supposed to make a decision between Apple and then Orange, or between iPhone and then Samsung, or between um, pursuing business or science? So that's decision variables. Then the second one is to take note of what the objective function. So what is your aim of making that decision? So let's say that you have you want to pursue, let's say, accounting and finance. So what is your motive of doing that? You get, so the objective function is it that you want to what, maximize the school fees you are paying, so that it's not like you study only one course and then if someone studies the two combined, they are paying lower or something. So you want to also do accounting and finance to maximize the fees you are paying. So that is your objective of making that decision. Someone's objective of making, maybe the person is a manufacturing company, they produce chairs and tables, so they want to know whether they should produce more chairs or more tables, and at the end their objective or their motive is to what, maximize their profit. So they want to know what decision to take, what unit of tables and chairs to produce that will make them get the highest profits. So that's the objective function. What is the aim of taking those decisions? Or you want to minimize costs. Maybe you want to produce tables and chairs, and then you want to know the quantity to produce so that your cost will be relatively cheap in order to make higher profits at the end. So it depends. That's the objective function. The next one is constraint. We know that human wants are what's insatiable, right? We have so many wants, so many needs. So, but we are what, limited by our resources. We don't have enough resources. You can't say you can have the amount of money you need to satisfy everything that you want. Sometimes you may go to the shop in this time where inflation has hit various countries. You go there and the prices have increased and your money is not even up to what you want to buy. You have to reduce the what quantity you are purchasing at that point, you see. So that those are the constraints, our resources. That's what we are limited by. That's the resources. Then the last thing is to look at what the non-negativity. So this one is talking about the decision you are making. Will it reach a point where there will be negatives in? So let's say you are producing a chair and a table. I'm not sure you have a negative chair. Like you can't produce and the chair will be negative. It's impossible, right? But let's say you have cash balance, cash flow. You can have a negative cash flow. That's when your cash outflow outweighs your cash inflows. You can have negative. So with this, there can be what, unrestricted sign. Can have a negative, but there are some that they are mostly, you can never have a negative. You can have a positive, right? So that's what you have to take note when you're formulating the issue, the problem, translating it into mathematical form. Know your decision variables, the objective function, then constraint, and then non-negativity. So when we come to the objective function, we have to, there are contributions of the objective function. So let's say that if you want to make decision on whether to produce chairs and tables, there you have to know what contribution of tables will what add up to my profit. So let's say after making the tables, you want to sell it for 50. So it means a table is contributing 50 cedis to your what, to your profit. And maybe a chair will contribute 30 cedis to your profit. So with the objective function, you have to what, bring these contributions. Because you want to maximize profit, you have to know how much each item contributes to the profit. You get it? Okay, so that is basically what we are going to do here. And then with the decision variables, you have to define them. All right. So let's say you are producing chairs and table, and then you are saying, okay, so we don't know the amount of chairs to produce, don't know the amount of tables to produce. So let's say want to make X1 represent something, X2 represent something. Don't just say X1 tables, X2 tables. It doesn't make sense. If you have gone to your management and are saying that, okay, so let's make X1 represent tables, your management will not understand. So you have to write what X1 should represent what the unit or the quantity of tables to produce. That makes sense, right? So any layman who takes that information will be able to understand where you are coming from. But if you just say X1 tables, I don't give much information to what any layman. You get it? So when you are defining the decision variable, you have to add. If it is about units, add. If it's quantity, add it to it. If it is gallons, add it. If it is liters, add it. You see, so to make sense to the person who doesn't know the question itself. Get it? All right. So I want us to see a question so that we just formulate. In this video, we are just going to formulate the issue. So I have this question here, as we can see. Please don't exit the video, like and subscribe, and God will bless you. All right, so we are using this question. Question says, Craft Sandals Limited manufactures two popular sandals identified as sandals A and sandal B. Each show each shoe, it was a grammatical mistake. Each shoe has its lowest possible production cost when produced on Craft's new production line. So with this Craft Sandals Limited, they are into the production of sandals. And let's say they have what types of sandals we have. I don't know brand name, but let's say sandal A and sandal B has given in the question. And then this one, they are dealing with costs. So their focus is on how to make the lowest cost, not to make the highest profit. So reducing cost, that's the focus here. So each shoe has its lowest possible production cost when produced on Crack's new production line. So they've adopted a new production line. Say they brought in a new machinery, and then when you use that machinery, you can produce the sandal at a lower cost, right? However, the new production line does not have the capacity to handle the total production of both sandals. So there's a total number of sandals the business produces to sell. But then this new machine cannot produce everything. Though if we're able to use it, then we could have gotten lower cost. But here lies the case, it can't produce everything. So as a result, at least some of the production must be routed to a higher cost old production line. So that means when you're using the old production line, your cost is going to be high, right? It's normal. Any old thing, let's say you're even wearing old sandals and you're walking, it's likely that your legs are going to hurt you compared to wearing new sandals where you just move fast, 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 and then you are okay. So in the same way with the sandals, I use an old production line, the cost is going to be high. So the table below shows the minimum production requirements for the next month, the production line capacities in units per month, and the production cost per unit for each production line. So from the question, what is your decision variable? So you have to know the four things under linear programming: formulating it, decision variable, objective function, the constraint, and the non-negativity. So you have to ask yourself, what are the decisions that I have to make? Decisions concerning what? So in this question, you know that the decisions concern sandals A and then sandals B, right? So the decisions concern sandals A and sandals B. So we don't know the quantity you're supposed to produce for sandals A yet. However, we can use variables to represent. Let's come here. So with that, so let me use a new. So here we are looking at the decision variable. We are saying that decision variables here concern sandals A and sandals B. A and B are different. Since we don't know the quantity to produce yet, Then we have to represent them with unknowns. So you can say let x1 and x2 represent what? The quantity of what? Sandals A and sandals B to produce respectively. So the respectively here is trying to associate x1 to sandals A and x2 to sandals B, right? Okay. So this is how you would define your decision variable. So if anyone reads this and the person has yet to even see the question, person can relate to what the question is demanding. That we don't know the quantity to produce for A and B yet. So that's the decision variable. So that's where you start. So this one, you get a mark for that. Then we move on to our objective function. So what is the aim of what this Crass Sandals Limited? What is their aim? To know the amount produced for A and B. Their objective is to what? Minimize costs. So from the question, you see that their objective is to what? Minimize costs. That's minimize your production cost. That's why they went to buy the new machine, the new production line. They wanted their cost to reduce, but they can't produce everything on this new machine. You see, so they have to consider the old machine. But at the end, you have to produce in such a way that their cost will not be very high in order to make their profits very low. You see. So that's the objective function to minimize costs. Sorry. So we can write here, but minimize costs. And then we said that with objective function, there is always a contribution from each variable. So if the objective is to minimize cost, then in general, you have to know the amount or the cost that comes with producing on the new line for A, the cost that comes with producing for the new line for B. So this table, you have to be careful because this is production cost. So this is the contribution that each sandals will make to cost when produced on the new line or the old production line. You get it? So if sandals A is produced on the new production line, each sandals produced will cost 30 cedis. If it is produced on the old line, then means each sandal would contribute 50 cedis to the cost. So with the objective function, you would pick the sandals A, then sandals B. But then you see that in defining the decision variables, the question has already defined it for us. You can see from here, right? Has already defined it for us that XAN is unit of this. So in our case, we don't need to define it. But if you're supposed to define, just rewrite this. You get it? But in some questions, you won't get that production line A, production line B. So you have to use something like this, X and Y, or X1 and X2 represent this and this. You get it? But this case, they are using two different production lines. So they define it for us to make it easier for us not to get confused. So at this point, we'll say that this one will just erase this decision variable here. And then it's already in the question, so you just copy then paste. I only do it here, but in some cases, in some questions, they're not going to make it complex like this question where they are giving you production A, B. No, they're just going to make it simple. But here lies the case. We have sandals A on the new production line, sandals B, A on the old production line, sandals B on the new, sandals A on the old. So we get that one. So Here, Sandals A on the new is contributing 30. So this XAN is contributing 30 to the objective function. XAO is contributing 50 to the objective function. BN is contributing 25 to the objective function. And then C is what? XBO, sorry, is contributing 40 to the objective function. The objective function is the easiest. Whenever you see something like, maybe not in this question, maybe another question, you say, Sandals A, when sold, when sold at, let's say, 20 cedis per unit, or Sandals A is sold at 20 cedi per unit, Sandals B 30 cedi per unit. So when you see those 30 per unit, 20 per unit, those become the contribution for the objective function. So all you have, go to your objective function side, write the contribution attached to what the variable here, then you add the rest. So with this one, 30, so it's to minimize cost. So the contribution from the new production line for A is 30. So you write 30 and then XAN. That's handouts A on the new production line. But we use X because we don't know the amount we're going to produce. Then from the question, the old production line for A contributes 50, right? So you write your 50 X what AO. That's handouts A on the production line. Plus, now you're going to handouts B on the new production line, which contributes 25. So we have 25 what X B what N plus 40 X B O. That's handouts B on the old production line. So this will become your objective function for this linear problem. Hope you understand this. Then we move on to our constraints. So in all the decision variables and the objective functions are very easy. When they come to the constraint, that's where the problem lies. You get it? So with constraints, so let's say this decision variable and this objective function is subject to the constraint. So that's where you are going to read the question carefully. That's where the English works here. So let's read from this side. So this is where the resources come. So the constraint was talking about the resources. So it said as a result, at least some of the production must be routed to a higher cost. That's the old production line. The table shows the minimum production requirement. So let's move to our table. Then the table is telling us that Sandals A, right? The minimum production requirement for Sandals A is what? 50,000. So that means when we talk about minimum, what do you understand by minimum? So when you say something is minimum, you bring it in my local dialect, it's something like anye kra, one produce kra, nenye 50,000. So if for nothing, or if nothing is produced at all, not 50,000 of what Sandals A. You get it? So that's the least amount you can produce for Sandals A is what 50,000. So you can produce 50,000 or more, right? But Sandals A is not produced on one production line alone. It's produced on production line, but the new line, the old line. So that's telling us that the combination of Sandals A produced on the new line plus the combination of Sandals plus the combination of Sandals A produced from the new line and the old line should be at least 50,000 or more. So when you're bringing this into mathematical sense, when you hear at least, it means greater than or equal to. Greater than or what equal to. And I know we all know greater than or equal to, how to write that. And then when something is, let's say, it wasn't minimum and they had said maximum. When you say maximum, it means the highest you can reach. That means you can't go beyond that. So let's say you're writing an examination, they are telling you that your maximum time is 3 hours. How do you understand? It means that you can either finish before 3 hours or finish exactly 3 hours. You can't go beyond that. So with maximum, it will mean what? Less than or equal to. Sometimes they will say you have you can produce but only 50,000. It means that the maximum you can produce is 50,000. Sometimes the English can change. So when they say you have, let's say, not in this context, another question, you have 50,000 cedis. So formulate this program to suit your available resources. So when you say something is available, that's what you have, but you can choose to spend either that or less. But you can't spend more if you have 50,000 cities. How can you spend 60,000 cities? You get it? So when we say available, it means less than or equal to. Sometimes when you are reading, don't be in a hurry to get to equal to. So normally with linear program and their constraints, they're either greater than or equal to or less than or equal to. It's just in rare cases that you get, let's say, it's as equal to. So for equal to, the question might say exactly this, the same as this, not more than, not less than. You get it? But usually it's greater than or equal to, less than or equal. So you have to know which one is talking about greater than or equal to, which one is talking about less than or equal to. So if it is maximum, it's less than or equal to. You can write it down. If it is minimum, it's greater than or equal to. If it is but only, it is less than or equal to. Do you get it? All right. So with this, because it's saying minimum, so it means greater than or equal. So it's telling us that XAN, that's sandals A, on the new production line plus the quantity of A on the old production line should be greater than or equal to 50,000. So we'll write that here. So that will be our first constraint. And it will be what? Sandals A. But the constraint is on sandals A. That is what? X what? A, and that's sandals A on the new production line plus sandals A on the old production line should be greater than or equal to 50,000. That is minimum requirement. The least you can produce 50,000. You can produce that or more. So this is for sandals. Sandal A. That's the first constraint, the first restriction or restriction. Sorry. The first restriction given is that when the total you can produce for sandals A, whether on the old or new combined, should be greater than or equal to 50,000. Then we'll go back to the question. So with this, it's not automatic. It's the English. So you have to understand. You get it. So the next one is sandals B. When you produce on the old production line and you produce on the new production, when you combine, the minimum total quantity that you should get for B should be 70,000. Either that or more. But the minimum should be 70,000. So this is talking about greater than or what equal to. So the second one is on what? The second constraint is on sandal B. It is telling us that the quantity of sandal A, right? Sandals B, sorry, produced on the new production line, plus the quantity of sandals B produced on the old production line should be greater than or equal to 70,000, right? So that's our second constraint. So it means you are done with the minimum requirement. We've seen that there's something here, production line capacity. You see, we've dealt with the 30 CDs and the 25. We've dealt with the 40 and the 50 in the objective function. It means we have nothing to do with that here. You've dealt with the minimum requirements. It means you are done. But we still have figures here. It means you have to do something to that. So always have to check the figures that you get in the question. Deal with each of them. When you are done dealing with them, making sure that they are in the constraints, then it means you are done. But if there are more, it means you have to work on them. So there are additional 80,000 and 60,000 here, right? And then you are saying production line capacity. right? So, and you see that they are all under new line. So it's telling us that when you produce sandals A and sandals B on the new line, the um the the maximum that the new line can hold or can produce is 80,000. So you see that from the question, they bought a new machine. They wanted it to use it to produce A and B, but it can't produce everything, right? So this is telling us that the maximum that this new line can produce for both A and B is 80,000. You get it? That is the maximum it can produce. So you have to understand the question. They are saying that the new line doesn't have the capacity to produce everything that we need for what A. So you realize that the minimum requirement is 50,000 for A or more, 70,000 for A or for B or more. So in Adam is 120,000, but a new line can only produce 80,000. You get it? That's why they had to shift to old line. So this aspect of the table is telling us that sandals A produced on the new line plus sandals B produced on the new line should be less than or equal to 80,000. That is maximum. That's the meaning here, maximum. So you have to what? Understand English plus understand the mathematical translations. So this is an example to just let you know that sometimes you have to take care of every figure you see in the question, every number you see there, it should be taken care of. You have to know which ones are objective function. But you see per unit, maybe 30 per unit of this decision variable, 20 per, it means it's a contribution, it's for objective function. When you see like at least produce this, the maximum produce that, but only, it means there are constraints. You get it? So the next constraint is what the production line capacity. And then you label the first one on the new line. It's saying that the quantity you produce for what A on the new line plus the quantity you produce for what B on the new line should be less than or equal to what 80,000. That's the maximum you can produce on the new line for either A or B or both combined should be 80,000. So that's your next constraint. So you have to see, is there any other figure left? Yes, we've not worked on the 60,000. The 60,000 aligns with the what old line. So which is telling us that when we produce A and B on the old line, the maximum the old line can take is 60,000. It can't take more of that. Either it can take 60,000 or less, but it can't take more of that. That's what the table is telling us. So it's telling us that on the old line, the quantity produced for A on the old line plus the quantity produced for B on the old line should be a maximum of what? 60,000. As maximum, the least should be 60,000. It can be 60,000 or less, but shouldn't exceed. So when we check our question, you see that we've dealt with all the figures. There's no other figure here that we have to do. It means we are done with our constraints. So this is how the constraints would look like. So in this question, they define our decision variable for us perfectly. Then they give us constraints, and then the constraints are four. You get it? So the last thing in the formulation is what? Non-negativity, which is very, very important. Non-negativity. So, non-negativity, which is telling us that standards and pairs sandals cannot have negative. Let's say you produce and you've gotten a negative sandals. Hey, I've never heard some before. I've got a negative orange. No. It means if you are getting negative for your answers, you're on the wrong path. So non-negativity constraint is telling us that X, that's the quantity produced for A on the new line. The quantity produced for A on the old line. The quantity produced for B on the new line and the quantity produced for B on the old line should be greater than or equal to 0. As it can either be none, that's when you produce for handouts A on the new line, it can be 0. But it should either be 0 or greater than that. You can choose to write sandals A on the new line greater than 0, sandals A on the, but I've combined all because they are all greater than 0. You get that? Okay, so that's how we formulate our linear program. So the question is full of English, as we can see here, but then this is the mathematical expressions they expect from us. So if you know your steps, starting from decision variables, objective function, which is will minimize cost. That is the objective of this business, to minimize their cost. You know the limitations, as the resources that are limiting them to produce as many as they want. That is your constraints. As these variables and the contributions are subject to the following constraints. And the constraints, you have to deal with each and every figure you find in the question. Make sure there is no amount figure left, else you are not done. Get it? So the constraint, you have to be careful. This is talking about greater than or equal to, less than or equal to, or equal to. You have to know the English language. So you can write these now. If it is available, it is less than or equal to. If it is maximum, less than or equal to. If it is greater than or equal to, it's talking about minimum requirement. Minimum, greater than or equal to, but only less than or equal to. More than, this or more than. That means greater than or equal to. Cannot fall below this. That means less than or equal to that number. So you have to be careful with the English language. It can be tricky, but if you're able to understand how to come by your decision variables, how to come by your objective function, the constraint, deal with every number, the English, the available, the maximum, the minimum, then not forgetting your negativity. That's this item, this decision, can it be negative? Or is supposed to remain only positive, that's above 0 or 0. So this is where I'll end this session on linear program, the formulation. So you can copy this down, because if I'm working on the computation, I would use the computer or the Excel to do that later on. But I'll use the same question. So please like the video, share, subscribe, show love. You are in February, the month of love, right? So that's how you can show love to me. Subscribe and share and help someone. If you have any question, please leave it in the comment section and I will gladly respond to that. God bless you for watching, and I pray that a good Lord should open your mind, should grant you understanding to be able to differentiate between the various English words for this mathematical problem, and that all will go well with you. God bless you. God let his face shine upon you, and may you have a blessed time studying. Any question, please leave it in the comment section. And don't forget to subscribe. God bless you. Bye-bye.